looking at forces. So this question is saying state Newton's second law of motion. So we have first law of motion, which is also known as the law of inertia. We have Newton's second law of motion and Newton's third law of motion. So in talk of Newton's first law of motion, it states that when an object is in the motion, it is going to remain in the motion. And when an object is at rest, it is just going to maintain the resting position. For the Newton's second law of motion, it focuses on force being equal to mass multiplied by acceleration. So this means to say an object is going to accelerate in the direction of the force. And this one happens when there is unbalanced forces. So let's say, for example, if we have an object like this one, we have a force which is acting on this one and the force which is acting on this one. The force which is going to be greater, that is where now an object is going to accelerate. So if here we are having 20 newtons, here we are having 5 newtons, meaning to say an object is going to move on this direction, because that is 20 minus 5, that is 15, so it is going to accelerate on the left side. So in talk of Newton's third law of motion, this one focuses on for every action there is equal but opposite reaction. Okay, like for example, the way the rocket moves, or is going to be let me just say, when the rocket is being ejected from the where it is being launched, you find that the force is going to act downward, but the rocket will go upward. The force is acting downward, but the rocket is going where? Upward. So that is, for every action there is equal but opposite reaction. The force is going downward, but an object is going up. So for Newton's second law of motion, you can just write the formula if you want, and if you want, you can just say state that unbalanced forces, unbalanced forces always produce acceleration on the direction of the force. Produce an acceleration in a direction of a force. Question B. The following diagram shows a 4 kg box resting on a frictionless surface with the forces acting on it as shown. So what you need to understand is that force is a vector quantity, so it can be added or subtracted depending on the direction. So it has both magnitude and also the direction. So these directions, they are pointing on the left hand side, so we have to add them. So vectors which are pointing on the same direction, you have to add them. So we are adding 16 newtons plus 12 newtons. Then we are going to get 28 newtons. When forces are acting on the opposite direction, you have to subtract. So 28 is the sum of these two forces which are acting on the left hand side. So it's more like we have 28 here newtons, and then we also have 10 newtons acting on this side. So if the forces are acting on the opposite side, you have to subtract them. So when I subtract, let me just say, when I want to find the resultant force here, what should I do? So the resultant force is going to be equal to the greater force minus the lesser force. So greater force there, it is a 28 newtons, then minus 10 newtons. Then the answer is going to be 18 newtons. So this is you're supposed to answer that one. But this question is saying calculate the uniform acceleration caused by the force. So what we need to do here, we have to calculate the resultant force, and then we calculate the acceleration. Since we know to say that force is equal to, the resultant force is equal to mass multiplied by acceleration, then acceleration is going to be equal to force divided by mass. So in this case, we have already found what the resultant force is, which is 18 newtons. So we have to show it somewhere here, then divided by the mass. So the mass is in the question, which is 4 kgs. So if it is in grams, you have to convert it into kgs. So 1 kilogram is equivalent to 1000 grams. Okay, that is one thing that you have to know. So 18 divided by 4, I'm going to get 4.5. Remember, acceleration is measured in meters per second squared, so that is 4.5 meters per second squared. And then we are done.